are something that you have already looked at extensively in other classes, but I don't believe you have seen the sideways parabolas. Have you guys seen ones that are sideways before? Okay, so you should have seen a lot of parabolas for just standard up, like smiley face parabolas or sad face parabolas. You should have seen a lot of those. There's lots of different ways we can look at the equations for parabolas. They can be ones that are expanded. This is like ax squared plus bx plus c. That's what we're going to use like if we're doing quadratic formula sort of stuff. You might see it factored. We've done a lot of factoring in this class, so you should be familiar with that. In Math 2, you were supposed to do vertex form, which is what we're going to mostly focus on here today. But it's probably been a while, and I'm not sure how much it was focused on or not. But have you seen ones like this? It is, you have maybe not seen it look like this, but if I gave you something like this, y equals 3, x minus 2 squared plus 5. We have looked at some of these like this without calling it vertex form, because what does this minus 2 right here do? To the right 2. What's the plus 5 do? Up 5. And then what's that 3 do? Vertical expansion. So we've looked at these in vertex form, even though we haven't called it vertex form. So we can sort of use that same logic here for these problems. What's going to be a little bit more difficult is that if you switch the x and y's in a parabola, if you have x is just to the first power and your y is squared, it is going to create a parabola that either opens to the left or to the right, a sideways parabola here. So it can be given in expanded form as well. It can be given in factored form, but this is really what we're going to focus on here is vertex form for this. It's similar but backwards from everything we know about vertex form for a regular parabola, because we have x's switched with y. So we're going to look at that in more detail today. So, some general things about parabolas that we need to know. The typical parabola that we usually look at either opens up or down. So it's either a smiley face like this, or it might be a sad face parabola. And it's vertex form I showed you earlier. So one thing that we are going to need to know is this value right here, which is your, I'm forgetting what it's called. I think it's focal length, but I'm not going to write it down because I'm afraid that's wrong. It's not going to be terribly important, the name of it. It's not going to ask you for that. But it is 1 over 4a. So a being this number right here, 1 over 4 times that number is going to tell us where the focus of a parabola is. So the focus of a parabola is always on the inside of the parabola here. And then we're going to have an axis of symmetry. Axis of symmetry, if it's like this, is going to be vertical. If we're over here, our focus is going to be here on the inside of the graph. I guess I should label this focus. This is our focus. These green lines right here would be our axis of symmetry. I'm going to do AOS for that. And then we're going to have what we call a directrix. The directrix is going to be a line outside of the parabola. So this is the directrix. You guys have not heard these words before, have you? Not maybe axis of symmetry, but not directrix or focus for these. We did do focus for ellipses, so I know you've heard that in here. Have you heard it in conjunction with parabolas? You have, so you may have looked at it. In conjunction with, I just meant have you heard it dealing with parabolas? You could also use it in math as well, but we won't get into that. So this red line right here is the directrix. Now, for parabolas that open up or down, how can we tell if they open up or down? We'll have a negative in front of our x squared. In this case, it's going to be that a value right there. It's on the outside is going to affect it, so it's going to be whether or not that's positive or negative. If we're dealing with a parabola that opens to the left or right, if we have a value that's greater than 0, it's going to open to the right, which is our positive direction, and if it's less than 0, it's going to be to the left, which is our negative direction. And we will look at this stuff more in detail as we go through. Okay, questions so far? All right, so this is the definition of a parabola that I don't believe you've looked at before, especially if you haven't heard that word directrix before. You probably haven't. So a parabola is defined as the set of points equidistant from a point and a line. That point is called the focus, and that line is called the directrix. So I've made this on Desmos that hopefully still works from last year. Or the year before, whenever it was I made this. I think there it is. Alright, so it's kind of, that definition doesn't really mean a lot to us whenever we see all of those words. But what I have here is I have graphed this point right here. Let me change its color. Can I change its color? Let me make it orange. No, orange doesn't show up that well. Let's do black. No, it still doesn't look much different. So, look right here. All right, so that black point right there, that is the focus of this parabola. And let me zoom out a little bit. And then, this purple point is just any point on the graph, and I'm going to move it here in a second, so we'll see. So, this blue line right here is my directrix. So, for a parabola, at any point on this parabola, the distance from the focus to that point has to be the same as the distance from the line to the point. So, no matter where I'm at, notice these red dotted lines, they're the same length. So that's what this means as far as the definition of a parabola. So if we wanted to construct a parabola, and we could take a line and a point, and we could just use equidistant points from those along the way. There are several things that this could be used for setting up parabolas. There's a lot of things that are parabolic in nature that we use, like, I believe, hopefully I'm right about this, could be hyperbolic, but I think it's parabolic. Like the shape of a lens on your glasses are very, very, very slightly curved, and it has something to do with like how your glasses work. If they're for prescription, if they're just sunglasses, it's not the case. But I believe it's parabolic. I need to go look that up again because it could be hyperbolic. But they have a parabolic curve to them, very slight, right? Because it looks pretty much flat whenever you look at it. But I think they should be curved, possibly not even like visible with the naked eye. Like I'm pretty sure I can't tell on mine. Can you tell on yours, Paul?
No.
I can't really. But very, very slight lenses. Whenever we're looking at this, and I can't remember if it's parabolic or hyperbolic. I'll have to look that up. But lenses, it's also the case like in, especially in like microscopes and stuff like that. There's like a very slight curve to things that you'll have there. And you set that up, using this sort of stuff that you would possibly need. They tell me, I'm no like eye doctor, that I'm pretty sure like even regular eye doctors are not doing this. It's like somebody who's making the technology that makes lenses for glasses and those sort and microscopes and those sort of things, telescopes, all kinds of things like that. So don't take too much about what I'm saying, but it is used in certain aspects there. So this might be something that would be used. Also, I would just like for you guys to look at this really extensive math that I have right here. Look at that. I made all those with that formula right there to make this. So that's the idea for a parabola. There are also things like, is that parabolas or hyperbolas? I know it's like, like if you've got like power lines, or, I need to look this up too. I need to look all this stuff up before I try to talk about it. But like if you have power lines, or like if you look at that string that's hung up back there, they're going to take like a natural shape, and I want to say it's parabolic, but it might be hyperbolic. I have to go look that up so that I can tell you more about that. But these are things that you, like, obviously I did not calculate anything there. Whenever I hung up my little banner, and if you're hanging somebody's birthday banner, you're probably not going to, but if you have like high voltage power lines that stretch over like really long distances, it's something that you probably are concerned with, or something like that, in the design. Again, probably not the people putting up the power lines, but in design. So it's kind of cool stuff there. But let's look at, first off, one that's sideways. And what I'm going to do here, just so we got an idea, you're going to need to be able to sketch a graph of these, not give a really, really detailed graph, but sketch a graph of these using just your own knowledge, not Desmos. But the great thing about Desmos is it will graph almost anything. Your calculator won't do this because it can't graph anything that is y equals, but Desmos, it doesn't even care. If it's x equals, it can graph it, which is pretty cool. So you can see this is a parabola. It's on its side. If I graph x equals y squared, which would be like your basic sideways parabola, you can see that it's been shifted up and to the right. And you can see it also looks skinnier than that blue graph right there. So we have sort of those same things happening, but they're going to be a little bit backwards because everything is, x's and y's have been switched here. So let's talk about how we are going to find these without being able to graph them on Desmos. So you always want to start with your vertex. Actually, the very first thing you want to ask yourself is, does this open to the right or to the left or up or down? So if it is x equals, that tells you that it's either right or left. So whenever we see something that has just an x but it has a y squared, it's going to be a parabola that opens to the right or the left. And then once we get it in vertex form, which this one is already in vertex form, we're going to look at this number right here. If it is positive, that's going to tell us that we open to the right. If it is negative, that tells us left. In this case, which one is it? It is positive, so it is to the right. So we have a parabola that looks like this. So our vertex is going to be a little tricky on these. So whenever we think about transforming this graph, up, down, left, right, okay, what is this -4 right here going to do to the graph? What do you think? It should be right 4, and it would be right 4 if that was an x inside of those parentheses. But because it's not an x, it is a y, it's telling us whether it goes up or down. It is still inside of parentheses, which means it's going to go the opposite direction. So things that are inside of parentheses go opposite directions. But because there's a y here, this is going to go up 4. So normally, like our regular vertex would just be at 0, 0 if the parabola had not been transformed at all. So that means if we move it up 4, the vertex now is going to have a y coordinate of 4. So if this number inside is moving it up or down, what do you think this number on the outside over here is doing? Left or right? Is it going to be left or right? It is right. 3. because it is not inside of the parentheses, so it is going to go in the direction that you see. So positive direction is right. So to the right 3 means we're going to have a positive 3 for our vertex. So our vertex here is at 3, 4. All right, so when we want to find the focus of this, the focus in this case is going to be on the inside of the parabola. The directrix, which is a line, is going to be on the outside of the parabola. And it's not going to touch the parabola. It's going to run, not really parallel, I guess, but it's not going to touch it here. It's vertical in this case. So to find where the focus and the directrix are, we are going to use that formula that was over there. It's P equals 1 over 4A. And this is another formula that I am going to give you. So you don't have to have it memorized here. So A is the number that's outside of the parentheses. So in this particular case, P equals 1 over 4 times 2. So that is 1/8. Or I'm going to go ahead, just because it's a little bit easier here, I'm going to make that a decimal. So I believe that's 0.125 as a decimal. Your textbook, when you get to the work for this, is probably going to use fractions instead, but it's okay with me if you use decimals for these, because I'm mostly concerned with your understanding of what these are and where they are, rather than your ability to add and subtract fractions. So, although I do want you to be able to add and subtract fractions as well. So what this tells us is that this distance right here is 0.125, and this distance right here is 0.125. So, much like we've done with our ellipses and our hyperbolas, we're going to start from our center right here, which is at 3, 4. And if I want the focus, I have to go to the right. So for my focus, I'm at 3, 4, and I need to move to the right 0.125. So which coordinate am I going to change if I'm moving to the right? The x coordinate, right? And do I need to add or subtract? I need to add. So I'm going to have my focus at 3.125, 4. All right. Directrix is similar, but it's in the opposite direction, and it's a line, not a point. So first of all, we have a vertical line. What does the equation look like for a vertical line? X equals, right? So it is going to be x equals, and then my x coordinate right here at my center was 3, but I had to go to the left 0.125. So what do I need to do there? Subtract. So 3 minus 0.125 is going to give me 2.875. There. So that's my directrix. That's the equation of that green line there for me. And the last thing they ask for is axis of symmetry. And so axis of symmetry is that line that we could fold this parabola in half on. It is going to look like this. Since it is horizontal lines are what? X equals or Y equals? Y equals. What's the Y coordinate there? It is 4. We just pull that from our vertex, right? Our vertex has a Y coordinate of 4. You are not going to have to graph these like on graph paper. All I really need to see is basically like I encourage you to draw a little graph here to help you as you're figuring these out, to know which way they open, but I'm not going to make you graph them on my graph paper. Mm-hmm.
So for the focus, you just add that number for the directrix, you just subtract it.
Unless it opens to the left. So if it opens to the left, we would need to subtract that number because we'd be moving to the left, and we need to add that number because we're moving to the right. So, yeah, so opposite there, but you will either add or subtract it depending on which way it opens. Yeah. Mm-hmm.
So your focus and directrix kind of like foci?
Yes, they're similar. Okay, so let's try another one. Okay, now this one is not in standard form. So we need to put this one in standard form, which is going to be a little bit like the circles and ellipses, but also a little different. It's still going to involve completing the square, but it's going to be a little bit different. So, y equals 2. I'm going to factor 2 out of my x's right here. X squared minus 4x plus blank. And then I've got that plus 5. I'm just going to leave it over here. And so I could, since I'm adding something over here, I could also add that same thing over here to this y. But I really want this just to be like a y equals equation, right? So would it be okay if I add something right here, but then I subtract it over here? Is that still okay? Like if I add 2, but then I subtract 2 to the same side, is that going to change that value? It's not, right? So it's okay to do that. So we could have actually done that on completing the square as well. With the others, it just didn't give us what we needed in that case. So here, instead of adding the blank to both sides, I'm going to add something here and then subtract that number from the end. Because if you add 10 and then subtract 10, it's like you never did anything, right? So we're going to complete the square. You only complete the square one time for these because you only have one value that is squared. So we'll have x. In this case, it'll be minus 2 squared. 2 squared is 4, so I have to put a 4 here. What number am I going to subtract? 8. Because just like with the others, you got to multiply it by whatever number is factored out there. So 5 minus 8 is going to give me negative 3 here. And that's going to put this in standard form for us. Okay, so first thing I want to do every time before I even think about vertex, directrix, focus, any of those things, I want to think about which way this opens. So if I see right here that this is a y equals, that tells me it's either up or down. And then I'm going to look at this a number right here. If it is positive, it will open up. If it is negative, it will open down. Which direction are we going to have for this one? Is up. So we have a parabola that looks like this. So that vertex is going to be that turning point there. And we want to think about shifting up, down, left, right here. This one is a y equals, so it works like it has been working, right? So this negative 2, what's it going to do to our point? It's going to go right 2. And so that's going to be our x coordinate here. We're going to have positive 2. What's this minus 3 going to do? Down 3, so it's going to be a negative 3 for our y coordinate. So that vertex that we have right there is at 2, negative 3. Our focus is going to be on the inside of the parabola. Our directrix is going to be on the outside of the parabola. So for our focus and our directrix, we need that p value, which is 1 over 4 times a. What is the a for this one? 2. So we get the same thing we had on the last one, that 0.125. You'll get different numbers. chose two problems that were similar in that aspect. So, for this time for the focus, I've got to go up 0.125. So if I go up 0.125, which coordinate of the vertex is it going to affect? Y. And what should I do? Add or subtract? Add. So you're doing negative 3 plus 0.125. So you're going to get 2, negative 2.875. Directrix. Horizontal line. X equals or Y equals? Y. And then I need to, my Y coordinate here was negative 3. I need to go down 0.125. So I'm going to subtract. I'll get negative 3.125. My axis of symmetry is vertical. X equals or Y equals line? X equals. Axis of symmetry, the vertex is on the axis of symmetry. What's your X coordinate there? It's 2. Okay, questions? Okay. Let's see, let me see if I added, there's a type of problem I need to add in here, and I don't think I did, so I'm going to add something to this. Okay, I need to add a type of problem here, so let's do this to this problem that you have here. Let's just put a 4 right there in front of that x. So instead of x equals, we've got 4x equals y squared minus 12y plus 4. Actually, I'll tell you what, let's, just so I can make a point here, make that 3 instead, sorry. Let's do a 3. Y. Four just went too easily into that stuff. Yes, oh sorry, x. Thank you. Now, this is not in standard form. We need to put it in standard form. But that 3 right there in front of the x, if I divide that 3 off, I've got 1/3. This will actually go evenly. I got 4 and I got 4/3. And I do not want to have to complete the square with all these fractions. So if you see one like this, leave the 3 where it's at. You can still complete the square, and then we can deal with it at the end of the problem. Okay? So let's ask ourselves, before we begin anything, which way does this open? Up, down, left, right? It is going to be to the right. The y is squared, and it is positive, right? So we're, even though we don't have this in vertex form yet, y is the one that's squared, which tells us left or right. Since the y squared is positive, it's going to go to the right here. So eventually we want to solve for x, but to make our lives a little easier, we're just going to leave this 3 right here right now. We're going to complete the square. So we're going to have y squared minus 12y plus blank plus 4, and then I'm going to put minus blank right here. You don't do anything with this 3x on the left-hand side. What number is going to go in my parentheses here? 6, so minus 6. What number do I add up here? 36. What number do I subtract over here? Again, a 36. You didn't factor out any numbers there, so it ends up just being the same number on this one. And so 4 minus 36 is going to give me negative 32. Okay, so it's not quite in standard form yet because the x is not by itself. So what we can do is we can divide everything by 3. So we're going to divide this by 3. We're going to divide this whole term right here by 3 and this 32 by 3. So what this ends up being is we don't have a number out here, but it's like we have a 1, or sometimes you may actually have a number you had to factor out, and there's a number there. So we can write this way, 1/3 times y minus 6 squared. And 32 over 3, let's just do a decimal on that. Especially since I messed up this problem and won't have decimals. So 32 over 3 is going to be, yeah. So your book's probably going to use fractions, but it's alright with me if you use decimals. There. I would actually use a fraction for this. You could use point through repeating if you want, but it's sort of like a slope, so. Okay, so I'm going to draw this down here. So, like I said, this opens to the right. So we'll have a vertex here. Who can tell me the vertex? Okay, 6 is my y-coordinate. Good. Negative 10.6 repeating is my x-coordinate. Very good.
I just can't remember how to find any of those, like, vertex.
Okay, so vertex is whatever letter is inside of this parentheses, it is going to, that's which coordinate you're looking at, right? So since there's a y here, this gives you your y-coordinate, but since it's in parentheses, you got to use opposite sign. So you have the 6 here. So if this is a 6, then this number right here is going to be your other coordinate, and it is not inside the parentheses, so you keep the sign the same with it. Okay, here. And vertex is the most important one to get right because your vertex is your starting point for everything else, right? So, for focus and directrix, you got to have this p-value. I will give you the formula. P equals 1 over 4a. What is my a? It is 1/3. Good. So 4 times 1/3. And so that is 1 over 4/3. And dividing fractions is easy as pie, so we flip the second and multiply. So we get 3/4, which if we want to use a decimal here is 0.75, and especially since our vertex is a decimal, I'd probably use a decimal there. So that p-value, that's the distance that the focus is from the vertex. So the focus is going to be on the inside of the parabola, so it's going to be to the right. So if I start at the vertex and go to the right 0.75, what would that change about my coordinate for the vertex? X value, and I would need to add or subtract? Add. So it's like I'm adding 0.75 to that coordinate there to find the focus. So focus would be negative 9.916 repeating, and then the 6 just stays the same because it's going to have that same y coordinate. Okay, directrix is just going to be the opposite, except for it is a line instead of a point here. So vertical line this time is an x equals. And so this time we're taking that negative 10.6 repeating and we're adding 0.75. Oh, and subtracting, sorry. It's like you're adding because they're both negative. But so we get negative 11.416 repeating. okay, here. And then the last thing's the axis of symmetry. That is just a horizontal line. Horizontal lines are y equals, what is the y coordinate on that line? It is 6. We just pull that from the vertex because the vertex is on the axis of symmetry. Or from the focus because they both have the same y coordinate. All right, questions? All right. Okay, let's look at example 4. I've got y squared equals negative 4x minus 3. This kind of looks like it's in standard form. Is it in standard form? It is not, because your y squared is over here. So, what you're going to have to do for this is you've got to solve this equation for your x in this case. And I'm giving you mostly x equals ones here just because I know we're less familiar with those. So, if I've got y squared equals negative 4 times x minus 3, if I'm trying to get that x right there by itself, what would I do first? Divide by the negative 4. You also could distribute it. It would work that way as well, but I'm going to divide by that negative 4. So let's divide by negative 4. Over here, there's like a 1 there, so we got negative 1/4 y squared equals x minus 3. What would I do next, trying to get that x right there by itself? Add 3. So, I got negative 1/4 y squared plus 3 equals x. I'm going to turn that around and write it like this. X equals negative 1/4 y squared plus 3. Okay, is this in vertex form? Vertex form usually has parentheses. But can I complete the square on this? Do I have another y? Do I have like a y squared and a 3y here? I don't. I cannot complete the square. So usually vertex form has parentheses. But this is actually already in vertex form because I can't complete the square. It looks like this, y plus 0 squared plus 3. So we can think of it this way. Now, if there was a y right there with that 3, then we would need to complete the square and do vertex form for this. But there's nothing there. So this one is in vertex form. So first thing I want to do is think, which way does this open? Is it up, down, left, or right? Left or right? Which one is it? Left. Because I've got that negative 1/4 there that opens in the negative direction instead of the positive. So I need that vertex. What are the coordinates of our vertex? It is 3, 0. Be careful that 0 is your y coordinate because it's inside of the parentheses with the y. Okay? So this is the point 3, 0 here. We still got to do our p. So p is 1/4 times a. You can kind of ignore the sign on the a because we're going to worry about that whenever we do left or right. So just use like absolute value of a is fine. So what is 4 times 1/4? 1. So this is just 1. So this time our p value is 1. So we need, for the focus, we need to go to the left 1. So we'll have 2, 0. We'll just subtract 1 from that x coordinate. My directrix is going to be over here. And what equals 4? X equals 4 because it is a vertical line, which is going to be at x equals. And then our axis of symmetry. That is this horizontal line here. What is that? Y equals 0. Yeah. Okay, questions? Okay. Okay, we're going to do one of these X and Y intercept problems because I'm afraid this might... We're not going to focus on this a lot in class. I don't know that the homework asks you to do this, but I'm afraid this is something that you might need to see for for the ACT or something like that. So I do want to do one of these problems. So, and this is universal for any function, not just any of these conic sections, right? If I want to know the x-intercept, I can plug in 0 for y. Because if you think about graphing this, if it's an x-intercept, if it's on the x-axis, you know, that point might be like 2, but its y-coordinate has to be 0 no matter where it's at on the x-axis. So I'm plugging 0 for y. So if I want to know my x-intercept for this one, I don't even have to put it in standard form. If it's in standard form, that's fine, but I don't have to. I can just plug in 0 for my y's. So if I do that here, I'd have negative 9 times 0 plus 3 times 0 squared equals 30 plus x. And so that would be 0 plus 0 equals 30 plus x. It's just 0 equals 30 plus x. I could just subtract that 30 to move it to the other side. And I'd get negative 30 for my x. So x-intercept would be negative 30, 0 would be my coordinates. So what do you guys think we're going to do for a y-intercept then? Plug in 0 for x. So in this case, I'd have negative 9y plus 3y squared equals 30 plus 0. This is going to be a little tougher to solve. So that is, I'm going to move everything to one side, so I'm going to have 3y squared minus 9y minus 30 equal to 0. This one's a quadratic, so I'm going to divide everything by 3 since it will go. So y squared minus 3y minus 10 is going to equal 0. And that will factor into y minus 5, y plus 2. So y will equal 5, and y will equal negative 2. So my y-intercepts would be at 0, 5, and 0, negative 2. And this works any, like if they ask you this about circles or ellipses or parabolas or any type of equation, something you don't even know what it is, you can do the same thing for this. We are going to let's do this last one here. We do need to look at this one because we have not seen one like this. All right, so if I want to find the vertex and the x and y intercepts, so this is asking for a little bit different things. For the vertex, I need to put this into vertex form. So I'm going to take this x and I'm going to move it over here to the other side. And actually, I'm going to write it on this side. So, I'll have x equals 5y squared plus 30y plus 12. I cannot complete the square when I have that 5 in front of the y squared, so what do I need to do with it? I can't divide everything by that 5. Because it doesn't go into 12 evenly, plus I just have like an x over 5 here. We're just going to like factor it out. Okay? So we'll have y squared plus 6y, and I'm going to put my plus blank right here. Plus 12, and I'll put our minus blank here. So make sure if you have a number in front of that y squared, you're going to factor it out for completing the square a lot like we did with ellipses. And so we're going to complete the square here. 5 will have y plus 3 squared. We need to put a 9 right here in this blank. What number do I subtract from the end here? 45. Okay, so 12 minus 45 is going to give me negative 33. So now our vertex, where is our vertex going to be? Good. So that y coordinate is what's in here because it's in, where did my cursor go? So because it's in the parentheses, we do opposite signs. So we have this negative here, and then this is just our x coordinate. Now this one does not ask for focus and directrix and axis of symmetry. It asks for x-intercept and y-intercept. Y-intercept is really easy to find from this equation because if we plug in 0 for our y here, we can figure that out pretty easily. So that's going to be 5 times 3 squared minus 33, which is 5 times 9 minus 33, which is 45 minus 33, which is going to give us 12. So my x-intercept is 12. With your,
Could you find that by just looking at that first part right up there?
the original, you'll just, right here is probably actually the easiest place to plug that in. Because if you plug in zeros right here, then you do get that. So that's probably actually the easiest place to plug that in. For the y-intercept, you could go back to the original, or if you go to your vertex form here, you're plugging in 0 for that x. So you got y plus 3 squared minus 33. So you would have to add 33. You would divide by 5. So I'm going to leave that 33 over 5 right now. That's the end of first lunch. We go at 1:15. Although I bet people are going to do it wrong. You square root both sides. So plus or minus square root of 33 over 5 equals y plus 3. Subtract 3. Subtract 3. So your y-intercepts are going to be at negative 3 plus or minus square root of 33 over 5. So they're a little harder to find there. You also could just go from the original. You have to use quadratic formula. Your answer is going to look different, but it would be the same there. So your assignment is going to be from the textbook, and we're going to do, it's from the textbook, it's posted on Canvas. We're going to do 13 through 21. Graphs, I only need the graphs for like your personal benefit of seeing which direction it opens if it asks for focus or directory. So you don't have to do like a formal graph of those. I won't necessarily be looking at it. If you can do that in your head and don't have to graph it, that's okay. And this will be due on Tuesday because we do not have class on Monday because it's a work day. So have that for me, and then we'll review on Tuesday. And please wipe off your desk for me.